Hi everyone! In this video, we will focus on factoring polynomials using the factor theorem. The basic idea of the factor theorem is if our f of c is equal to 0, then x minus c is a factor of the given polynomial function f of x. In inverse, if x minus c is a factor, then our f of c is equal to 0, where our z is considered as the 0 of our function. Or simply, the value that will make the equation f of c is equal to 0 true. We use the factor theorem to factor higher degree polynomials. So let's have an example. Let's factor f of x is equal to 3x cubed plus 10x squared plus x minus 6, given that x plus 3 is a factor, or x plus 3 is a 0 of f of x. So the first thing that we need to do is to equate our factor to 0 to find the value of x. So x plus 3 is equal to 0 is equal to x is equal to negative 3. So therefore, the value of x is equal to negative 3. After that, we need to substitute the value of x to our equation. So this will become f of negative 3. We will change all the values of x on our equation into 3. So this will be 3 times negative 3 raised to 3 plus 10 times negative 3 raised to 2 plus negative 3 minus 6. Then afterwards, we need to simplify. So this will become 3. Negative 3 times 3. Negative 3 times negative 3 is positive 9 times negative 3 is equal to negative 27. Plus 10. Then negative 3 raised to 2 is equal to 9. Positive negative will become negative 3, negative 6. Let's continue simplifying. So 3 times negative 27 is equal to negative 81. So 10 times 9 is equal to 90. Negative 3, negative 6 is equal to negative 9. Now, negative 81 plus 90 is equal to positive 9 minus 9 is equal to 0. So therefore, x plus 3 is really a 0 or a factor of the given polynomial. Now, we need to find the rest of the factors. So in order for us to do that, we need to divide the given polynomial by the factor. So let's use synthetic division here. Okay, so in synthetic division, we're going to use this, negative 3. Then afterwards, we need to get all the coefficients of our terms. So this is 3, 10, 1, and negative 6. Okay, afterwards, let's proceed on the synthetic division process. So bring down 3. 3 times negative 3 is negative 9. 10 plus negative 9 is 1. 1 times negative 3 is equal to negative 3. 1 plus negative 3 is equal to negative 2. Negative 2 times negative 3 is positive 6. Negative 6 minus 6 is equal to 0. Since our remainder is 0, we will now proceed on converting this one into a depressed polynomial, or simply the result when we divide the two. So this will become 3x, since this is 3, it will become 2, plus 1x minus 2. Or simply, 3x squared plus x minus 2. Now, we can rewrite this one into the factored form. F of x is equal to our first factor, which is x plus 3, times our second factor, which is 3x squared plus x minus 2. Now, we already find the factor of the given polynomial. But this one is still factorable, so we need to simplify it. So this will be, so we need to find the values. We need to use the FOIL method, wherein we need to look for the value of -2 or the factors of -2, that when we multiply, we get -2, but when we subtract it to our first term or first coefficient, the result will be the middle value. So let's try -2 and 1. And 1. So, -2 times 1 is -2. Now, -2 plus 3 is equal to +1. So, our factor is equal to x minus 2 times x plus 1. But since we have a 3 here, we need to write 3 on the first part of our factor. So we have here x plus 3, 3x minus 2 times x plus 1. If you want to check it, you may perform the FOIL method. So after getting the factors, we are now ready to find the zeros of the function. So these are the factors. Now let's look for the zeros. So in order for us to find the zeros of the function, we need to equate all the factors to 0. So x plus 3 is equal to 0. Then the other one is 3x minus 2 is equal to 0. And x plus 1 is equal to 0. In order for us to get the value of x. So x is equal to -3. And the other one is 3x. So we need to move the constant over to then simplify. So our x is equal to 2/3. Then for the other one, x is equal to -1. So therefore, the zeros of our function is -3, 2/3, and -1. Okay, let's consider another example. Okay, let's say we have f of x is equal to x cubed plus 8x squared plus 17x plus 10. And we're gonna check if f of -1 is a zero of the function. Okay, so first, we need to substitute since it's already in f of x form. We don't need to equate it to 0 anymore. So we just have to substitute the value of x on the given polynomial function. So this will become f of -1. So -1 raised to 3 plus 8 times -1 raised to 2 plus 17 times -1 plus 10. Then simplify. So -1 raised to 3 is simply -1. -1 raised to 2 is +1 times 8 is equal to +8. 17 times -1 is -17 plus 10. Now, -1 plus 8 is 7 minus 17 plus 10 is simply 7. So, -7. So, 7 minus 7 is equal to 0. Now, let's proceed on the division process. Since x plus 1, so we can write it as x plus 1 is already a factor of our polynomial. Now, let's erase this and proceed on the division process. Let's use synthetic division. For synthetic division is easier to use. Okay, so let's get the value of x, which is -1. And of course, the coefficients. So we have here 1, the invisible 1, then 8, then 17, and 10. Okay. So, bring down 1. 1 times -1 is equal to -1. 8 plus -1, I should say, is 7. 7 times -1 is -7. 17 plus negative 7 is equal to 10. 10 times negative 1 is negative 10, and this is equal to 0. Now, we get the depressed polynomial, which is x, this is 3, so this will become x squared plus 7x plus 10. Now, this is our second factor. So, now we can rewrite it as f of x is equal to the depressed polynomial times our first factor, which is x plus 1. Now, let's simplify this because this is a perfect trinomial. So, we need to find the factors of 10 that when we multiply, we get 10, and when we add, we get 7. So, we have 5 and 2. So, 5 times 2 is equal to 10. 5 plus 2 is equal to 7. So, therefore, we have x plus 5, x plus 2 times our first factor, x plus 1. Now, these are the factors of our polynomial function. Now, let's look for the zeros of the polynomial function. So, equate all the factors to 0. Then, find the value of x. So, x is equal to negative 5, x is equal to negative 2, and x is equal to negative 1. So, therefore, the zeros of the functions are negative 5, negative 2, and negative 1.